So this is lesson 105, and we're going to be talking about the normal curve and probability. So it says, in the last 2 units, we have studied statistics and probability. These two fields of math are inseparable. Without statistics, probability would be a completely theoretical field. You would only be able to ask, if I roll a dice, what is the chance I get a 2? You wouldn't actually be able to collect data on what happened when you rolled the dice. So statistics is involved in collecting and organizing the data. Probability tells us chances of things. You would not be able to predict the chance it would snow or the probability that a person who came from a low-income family would graduate from college because you need data to start to estimate these probabilities. Statistics also needs probability. When you find a confidence interval, you are saying that there is a 95% chance or probability that the actual population value falls in that interval. Unless we collect data from the whole population, we are always taking a chance in our predictions, or we make our interval so large that it becomes meaningless. When you do an experiment, the P in p-value stands for probability. Probability lets us make meaningful inferences from the data. It lets us quantify our confidence. So today we're going to look at normal probability, specifically normal curve probability. Normal probability is a good example of the interplay between statistics and probability. Data from a population has been studied and found to be normal or close to normal. With a known mean and standard deviation, it is possible to find the exact probability of obtaining a value in a range or any value greater than or less than a given value. This is possible because the total area under the standard normal curve, given by this equation, is 1 or 100%. So when we use this curve, if I was able to find the area here, this would have an area of exactly 1. Calculus gives us the tools to find the area under the curve between two values. This area is equal to the proportion we are looking for. So if the area is 0.65, that's 0.65 out of 1. Okay, so basically whatever we find the area to be when we do this, that is also the probability. These methods are programmed into your calculator, so anyone can find these proportions even if they don't know calculus. The directions are on the next page. So looking at the next page, this is the calculator directions, and we'll be applying them to the first problem. So it says, a swimmer named Amy specializes in the 50-meter backstroke. In competition, her mean time for the event is 30.7 seconds, and the standard deviations of her times is 2.3 seconds. Assume that Amy's times are normally distributed. So we're going to find the probability that Amy's time in her next race falls between 28 and 35 seconds to the nearest thousandth. So on the calculator, so we're going to get these two things next to each other. We'll see how to do this. So the first place we need to go when we realize it's a normal probability problem is we're going to press second distribution. So that's second and then this vars button. And we're going to choose normal CDF. So we're not ever going to use this normal PDF. We're always going to use number 2. Now they ask me some questions. So first off, they're going to ask me what two values do I want to find things between. So we want to know the probability that Amy's race is between 28 and, just make this a little bigger, 35 seconds. So in my lower, I'm going to put 28, and in my upper, I'm going to put 35. Now, these are other symbols. This is called mu, and it's another symbol for the mean. So usually we use X bar, but this means the same thing. So her average, we're going to type in here, her average time was 30.7 seconds. And the standard deviation, so this is another symbol for standard deviation. It specifically is for population standard deviation. So we're going to put the standard deviation of 2.3 right there. And I will have notes for this. We're just looking through, one time. So once I get that, I press enter. And for some reason, I had an X here. Yours should be blank. And then enter again. And that tells me my probability. So we're rounding this to the nearest thousandth. So my answer is 0.849, or she has almost an 85% chance of that happening. So work-wise, this is what we're going to show. Okay. So work-wise, when we look at this, we're going to write down normal CDF to say that's what we're using on the calculator. And then we're just going to write down what our lower and upper are. So we're going to write down what we typed in our calculator. So we typed in 28 for lower and 35 for upper. Our mean, which is denoted by mu in this case, was 30.7. And our standard deviation here was 2.3. So there's our values. I am just checking one thing because I adjusted some numbers. Okay, yes, everything should work out there. I adjusted some values, but it should still come out to the same probability. So the next one, it says the probability that Amy's time in her next race is more than 35 seconds. So we're actually going to break down the work for it first and then go to the calculator. So normal CDF. Now here, I want more than 35. So I want 35 or greater. Okay? So my lower is 35. My upper, she could spend hours, days. Like it basically is positive infinity. So a way to type in positive infinity or about positive infinity on your calculator, you can't actually get to infinity. We're going to type something called E99 and we'll see that. So when we're going greater, we're basically saying from the smaller number up to positive infinity. Our mean, this is the same question, so our mean is still 30.7 and our standard deviation is still 2.3. So we'll go enter that in the calculator now. So second distribution, normal CDF number 2, lower is 35, upper, the E that we're going to use is actually this double E. So you press this, only one E shows up, but it shows 2 E's. So it's second this button and then 99. So that really means like 10 to the 99th power, I think, or something like that. The mu and the standard deviation, mean and standard deviation stay the same. And then we're going to press enter. And that gives me to the nearest thousandth 0.031. Okay, so we'll write down that answer and then we'll set up the next one. So the next one is our last case. Now we're going to go down to a lower value. So it says find the probability that Amy's time in her next race is less than 28 seconds. So we'll still write down our normal CDF. Upper and lower. And actually, I wrote those backwards, so we want lower first, right? So that's the first one we have to write down. Now, if we want it to be less than 28, the highest it can be is 28 to show negative infinity. Not that she can really have a negative time, but we're just always going to use that to say we're finding everything else in the curve on the lower side. So we're going to write negative E99 here. Same mean, same standard deviation. Okay, and then we'll enter those values. So calculator's out. So lower we said negative second E99, upper is 28, and we're leaving our mean and standard deviation the same. So this one I got 0.120 for that answer, okay? Now, we can do normal probability without actually thinking about the normal curve other than the fact that we know that we get to use that on a calculator. But now we're going to connect it back to some stuff we did at the beginning of the unit so we can really get a feel for what's going on. So now we're going to find the z-scores for the data values in this problem. So the z-score for 28 and the z-score for 35. So just as a reminder, a z-score takes a value, finds out how far it is from the mean, and divides by the standard deviation. So the z-score for the 28 from our first problem, it comes up actually twice. It comes up in the first and third, is 28 minus the mean, so 28 minus 30.7 over the standard deviation of 2.3. So that actually comes out to negative 1.2 for that z-score. So that's the z-score for 28. The z-score for 35, which is our other value, is going to be 1.9. Okay, so those are our two z-scores that we're working on in this problem. Now it says use the mean and the standard deviation for this problem to fill out the normal curve. And we're going to place the 28 and the 35 on there. Okay, so this is going back to the normal curve. We know the mean goes in the middle, so that's 30.7. Okay, then we're going to add and subtract one standard deviation. This f should not be here, this should just be a continuation. Okay, so I'll write that down. We have 30.7. We are going to add and subtract the 1.9. Okay, so that is going to give me 30.7 minus 1.9 is 28.9 here. Okay, so 28.9, that's not correct. Unfortunately, this is the problem I have the wrong numbers for, but I don't want to make a new video. So, hold on one second. So this is, sorry about that, 28.8. For this one, and then when I add it, that is going to give me 32.6. Okay, so we're filling that out, and then if we add two standard deviations in each direction, right, that's going to give me the next set of numbers when I add and subtract the 2.3. Okay. So this is a mess up video, but I don't feel like making a new one. So we're adding and subtracting the actual standard deviation, which is 2.3, not the 1.9, which is why I was having difficulty because I was looking at an answer key with the wrong numbers. So let's just fix that. Okay, so now we're going to add and subtract the actual standard deviation of 2.3. I probably got the 1.9 from a different problem I was doing. So now this is 20.4 here. Okay, and then when we add it, okay, that's going to give us 33. Okay, so now I'm just going to label the 2 and the negative 2. I could go to the 3 and the negative 3. Basically out here, I'm going to have 35.3. If I add another 2.3, and if I subtract another 2.3 in this direction, we are going to have 26.1. Now we want to say the big thing, so that was a little bumpy, but the big thing is we want to label where the 28 and the 35 are to start to understand what our answers mean. So the 28 is going to fall about in here, okay? The 35 is almost up to this 35, so that's in here. So when we look at our three questions, our first question, we said there was an 84.9% chance that we were in between the 28 and the 35. So if I go down here and I think about this whole area compared to the whole shape, it does make sense that about 84.9% of the area is in there. On the second question, letter B, okay, I got just 3.1% is out here. And that looks about right. About 3.1% of the area is out here. It's not very much. And then my last section, which is below 28, I had about 12%. Okay? So that's what your calculator is actually finding. It's finding the percent of the curve that's between those two values. Now, we don't see that because we're just typing a couple of numbers in normal CDF, but that's what it's finding.